Hi everyone, this is your math guru. In this video, I'm going to show you how to solve trigonometric values that are represented by letters. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. When a trig value or trigonometric value is represented by a letter, other trigonometric ratios or expressions can be written in terms of the given letter by using your reduction, your cofunction, your trigonometric ratios, your compound or double angle, or basic identities. In the example given, we have tan 21 degrees equals to t. Write the following in terms of t. We're starting with a tan 339 degrees. As noted earlier, we can use reduction, cofunction, compound or double angles, trig identities, or trig ratios. So therefore, to break down 339, I'm going to draw my cast diagram in order to determine which quadrant 339 falls into. In the first quadrant, we have 90 degree minus theta, or theta if it's an acute angle. We have 180 degree minus theta. We have 180 degree plus theta. And in the fourth quadrant, we have 360 minus theta. If you look at angle 339, that falls in the fourth quadrant. So therefore, using reduction, that is equal to 10 in bracket 360 degrees minus 21 degrees. 360 minus 21 will give us 339 degrees. And if we look at the value of 10 in that quadrant is negative, because the only trig ratio that is positive is your cos. So therefore, that's equal to minus 10, 21 degrees. In the question, we've been given the value of minus 10, 21 degrees to be t. So therefore, tan 339 degrees equals minus t. For B, we have sine 201 degrees to break down sine 201 degree using a cast diagram, that falls in the third quadrant. So that's equal to sine 180 degrees plus 21 degrees. And if you look at the value of sine in that quadrant, sine is negative, so that's equal to sine 21 degrees. Using a cast diagram again for our triangle, 21 degrees falls in the first quadrant as an acute angle. And if you look at the question, we have tan 21 degrees equals to t. That's a whole number, so that's over 1. And from your trig ratio, tan is opposite over adjacent. So if I go back to the diagram, I have the angle given, or the reference angle, to be 21 degrees. We have the side facing our reference angle, that will be our opposite. And in this case, that's equal to t. We have the longest side, or the side facing a 90 degree angle. That's our hypotenuse. That's missing. And then we have our adjacent. Adjacent is 1. So therefore, the first step is to find the value of our hypotenuse using our Pythagoras theorem. We have your hypotenuse squared, that's the longest side, equals to the sum of the square of the other two sides. So we have opposite squared plus adjacent squared. So our hypotenuse squared equals opposite squared, that's t squared, plus adjacent is 1, so we have 1 squared. So therefore, finding the square root of both sides, that will be hypotenuse will be equal to t squared plus 1. So therefore, to find the value of a sine, we have minus sine 21 degrees. Sine is opposite of our hypotenuse. So we have that as minus sine 21 degrees equals opposite. Opposite is my t minus t over, then the hypotenuse, root t squared plus 1. The third question says find cos, in bracket, negative 21 degrees. So find cos minus 21 degrees. Minus 21 degrees as the acute angle, and we can find that in the fourth quadrant. When we read clockwise, we have a negative angle. If we read anti-clockwise, we have a positive angle. So that angle, minus 21, falls in the fourth quadrant, and the value of cos in that quadrant is positive. So that's equal to cos 21 degrees. Cos is adjacent over hypotenuse. So using the same diagram given, we have adjacent. Adjacent is 1 over hypotenuse. That will be root of t squared plus 1. Let's look at D. D is sine 48 degrees. In order to reduce sine 48 degrees, note that our aim is to always work towards the angle 21 degrees. So I'm going to start by reducing that to sine of 90 degrees minus 42 degrees. 90 minus 42 will give us 48. And then using my cofunction, that's equal to cos of 42 degrees. Cos, that's a double angle, because cos 42 degree is also equal to cos of 2 times 21 degrees. And using the double angle identity, I have that as 2 cos squared 21 degrees minus 1. That's equal to, we already have the value of our cos 21 degree from the previous question. So that's 2 times, I'm going to put that in a bracket, that's 1 over root of t squared plus 1 all squared, because it's cos squared 21 minus 1. And if you simplify further, that is 2 times 1, that's 2 over, then root t squared plus 1 is equal to t squared plus 1 minus 1. Then we go to our E. E is cos 132 degrees. To break down 132 degrees, if you look at a cast diagram again, we have 180 minus theta, we have 180 plus theta, 360 minus theta, theta or 90 minus theta, then that's a cast diagram. 132 falls in the second quadrant. So to break that down, we have, or to reduce, cos in bracket 180 degrees minus 48 degrees. 180 degrees minus 48 degrees will give us 132. And if you look at the value of cos in that quadrant, cos in this quadrant is negative because only sine is positive. So that's equal to minus cos 48 degrees. Now, like I mentioned earlier, our aim is to work towards 21 degrees. So I'm going to use my cofunction to change that to minus cos 90 degrees minus 42 degrees, like I did for sine in the previous question. And if we use a cofunction, that's minus sine 42 degrees. Cos 90 minus 42 is sine 42, and because of the negative in front, I'm adding that. And using a double angle, that would be minus sine 2 times 21 degrees. And using the double angle identity for sine, that's equal to minus 2 sine 21 degrees cos 21 degrees. Simplifying further, I have that as minus 2 or negative 2 sine 21 degrees, that's t over root of t squared plus 1 close bracket, and cos 21 degrees will be 1 over root t squared plus 1 close bracket. The final answer will be, for our numerator, negative 2t over a denominator t squared plus 1. And the last but not the least, we have our f. F is cos 39 degrees. To break down 39 degrees, I'm going to use my special angles. Remember, we're not to use a calculator. So using our special angles, I have that broken down as cos. That's another way of writing our angle. That's 60 degrees minus 21 degrees. I'm still working with the angle 21 degrees as given in the question. 60 degrees minus 21 degrees will give us 39. And therefore, using a compound angle, cos A minus B, we have that as cos 60, cos 21 degrees, plus sine 60 degrees, sine 21 degrees. That's equal to 1 over 2 times cos 21, that's 1 over root t squared plus 1, plus sine 60, root 3 over 2 times t over square root of t squared plus 1. That's equal to 1 times 1, 1 over 2 root t squared plus 1 plus t root 3 divided by 2 root t squared plus 1. And if I put everything under the same denominator, that's our common denominator of 2 square root of t squared plus 1. For our numerator, we're going to have 1 plus t root 3. Thanks for watching. Bye.